Alright, welcome to our lesson video about combining radicals. And when I say combining, what I'm talking about is adding or subtracting expressions with radicals. So, something to know, if you think back to Algebra 1, if you had 3x plus 4x, you could add those because those were like terms, and they would actually add to 7x. So it's that same idea with radicals. We want like terms, so we want like radicals. We need the same root houses with the same things inside of them. So these are considered like terms because they both have a square root house and they both have a 2 underneath. Over on the right of the screen though, labeled not like terms. Why are they not like terms? Well, this guy is a square root, so we're taking a root of 2. But this other house is a cube root, so these numbers are different, so I could not add them because of that. Okay, so the key here is the same root house with the same things underneath. So let's start easy. I've got cube root of 7 and cube root of 7. Those are like terms, so I'm just going to add the 6 and the 9 to get 15 cube root of 7. And that's it. Okay, notice how the radical did not change. In example B, are they like terms? Square root of 3x, square root of 3x. Yeah, the houses are the same and they have the same stuff underneath, but there's no number in front of this first one. Well, yeah, there is. There's a 1. So all we're doing is 1 minus 5, which gives us negative 4, square root of 3x. All right. Now example C, they both have a cube root house. This one has an x, this one has a 2x. There's a 1 in front of that x. Are those exactly the same? We've got a 1 and then a 2. Those are different, so I actually am not allowed to add those. I can't. So maybe an ACT as an answer choice might rewrite this expression without changing anything. And that would be acceptable. Or they may have a choice of cannot combine or something of that nature. Okay? Regardless, I cannot add this to one radical. I'm stuck with this expression as it is. Now, we must be careful because when you're combining radicals, there's a slippery slope to a death trap that will get you if you're not paying attention and you're not being lazy, okay? Notice on example C, they were different. However, 1 and 2, I could not factor them anymore. If you have root houses that are the same, but they have different things underneath, and you can factor, you should always factor or else you're going to be wrong from the start. Okay, let's see what happens with this guy. It's a cube root house, so I factored my 8, and by golly, I've got a pair of triplets. Okay, so that first term isn't going to change. How is the second one going to change? Well, I'm going to be able to take a 2 out since I had a set of 2's. What was left? No number, but the letter X. Now, can I actually subtract these guys? I actually can, and it's going to be an answer of 2 cube root of X. So you see how if you were being lazy and just flipping through, you would have said can't combine and you would have been wrong. So be careful. Whenever you can factor and do a factor tree, you always should. So that's what we're going to do on this example E. I'm going to factor tree 45. 3 and 3. And remember, it's a regular square root house, so I'm dealing with pairs. Okay, so a 3 will come out. What's left inside? A 5, and don't forget about that x. Now you might be thinking, well, 5x and 20x, those are different. Yeah, but I still can't draw a conclusion. I still need to factor this 20, and oh my goodness, look what happens. Same thing, I get a pair. Now, I already have a number outside, and I'm bringing a 2 out from this pair. So what do I do with those numbers? I actually multiply them to get 6. So let me put a little quick side note. We did 3 times 2, and that's how we got 6. And what's left in the square root house? We've got a 5 and an x left over. Oh my goodness, they're the same again. So I can actually add them to get 9 square root of 5x. Okay, now this one, I can factor tree my x's because I have 3 x's. And because it's a regular square root, I'm looking to make pairs. And I can definitely make a pair of x's. So there's a 5 outside already, and now there's going to be an x because I had a set. I'm going to have an x that comes out. Now what's left? That plain old x. Now this 4, I'm going to factor it, and I've got a pair of 2's. So for the second term, there was an x outside, but from this pair, a 2 will come out. So I have a 2x. Okay, and what's left? That single x. So man alive, if you were just being lazy with these, you would have gotten what, 3 of them wrong already? You've got to factor tree because look, a lot of these guys actually do combine. And when I subtract 5x minus 2x, I get 3x. And I'm just going to keep the square root of x. All right, nice. Now I might skip ahead on some of my examples. Let's see. I guess I only have 2 more, so I can do them real quick. Let's see. I'm going to factor tree my 48. I think I'm going to go with the pair 16 and 3. And so 4 and 4. So I'll have 2, 2, 2, 2. And I only have 1x. So I'm looking for 4 of something to make a set. So I've got a set of 2's. So a 2 would come out from this first term, and ooh, I think that's it. So what's left? A 3 and an x. Those guys are going to go back under the 4th root house. Remember, whatever root you started with, make sure you have that root if you have anything left over. Okay, the second term. You know, I can't factor a 3. I only have 1x. Ugh, that second term's boring. There's nothing I can do with him. So let me just rewrite him. Okay, and they're the same radicals, so I would actually get 9 4th root of 3x. All right, we've got one more, so let's buzz through this guy. I'm going to factor tree again because I can. And I think I'm going to go with the pair 2 and 27, 3 and 9, 3 and 3. And remember, I have 5 y's. So let me go back to my index. I need triplets. That's what I'm looking for. So, ooh, I've got 3 3's. And, I've got 3 y's. So what's going to come out? From a set of 3's, I'm going to have a 3. Because I have a set of y's, a y. That's everything else. All I've got now is this leftover stuff. So let me make a cube root house and put it all back in. 2. And then I have y and a y, so y squared. Now let's look at the second guy. Well, I can't factor tree a 3. And I only have 2 y's. I don't have enough to circle a set. So, here's another boring second term. Man, he's going to stay the same. Let me just rewrite him real quick. Now, can I add these guys? They both have a cube root. They both have a y squared, but, oh, this could be a deal breaker. That one has a 2. That one has a 3. They're different. So again, think of an ACT as an answer choice. They may just rewrite this as a choice, or they could possibly say something like cannot combine. So if you missed class and you're watching this lesson video, here's the homework. Or if you're just watching these videos again, this would be the next video to watch. After we talk about combining radicals, we talk about rationalizing. So keep learning, guys, and have fun. See you next time.